So the other day I was on a call, and it was a frustrating call because I was talking to a human being, but it felt very much like talking to a machine, where I could say a phrase and then I would get a consistent phrase echoed back to me. And it made me think of the Zoom bingo concept that's been taking root in the current pandemic. And I thought, as a fun little code kata, it'd be interesting to try and build a Zoom bingo concept in Angular 10. So the idea here is that you have a bingo board, this 5x5 card, which has a number of phrases here that, or I guess a number of things that happen during a Zoom call, such as a dog barking in the background, or someone has to have a hard stop, the pet photo bomb, so on and so forth. And the idea is you want to collect a number of items in a row. And as an additional part of this code kata, I thought it'd be fun to use the HTML to Canvas library to then be able to take a screenshot of this board, right? So now you can see this is an image, and I could save this image and send it to other people. Now, one thing that is also interesting here is that if you look in the URL, you can see I have this large base64 URL encoded value, and that's because the items within the board are actually persisted to the URL. So I could come in here and I could edit these things. For example, we only have 24, and if I put a bunch of X's in here and I save, you can see there is our XXX. Now it's down here in the bottom right, but if I refresh, you'll notice that it's over here now, and now it's over here. And that's because what's happening is every time the board refreshes, it randomizes the selection of the phrases that are persisted in the URL. And of course, because these are persisted, I could put this into a new tab. I could paste it to someone else, and you can see they have the same options, except their values are in a different place, right? Okay, so let's take a look at how this works under the hood. I tried to keep it simple, but still sufficiently interesting. Now that we understand what we're seeing, let's look at the code, but let's look at it from the bottom up. So rather than looking at the overall app, let's look at the parts. And the first one I want to look at is the bingo board component itself, which you'll see takes a collection of phrases, and then what it's going to do is it's going to randomly select a number of phrases, making sure that it has up to 25 phrases for the board. And if it doesn't have 25, it adds this filler phrase, which is this free space concept that anyone could use on the bingo board. And then using the magic of CSS grid, you can see that the output or the template of this component is super simple. This is a list here. The list is actually using CSS grid. It's a 5x5 grid, and I just loop over the items and I output the values. And then I have this hash of selected indexes, and that's just to keep track of which spaces have been toggled on and off. Easy peasy. All right, the other part of this is the form, which itself is also fairly simple and again works on this unidirectional data flow with some two-way data binding internally. Like the bingo board, it takes an input of phrases, which it then translates into these form fields in its view. And then when the user is done updating the phrases, it emits this phrases change event, which we can then use to repopulate our game state. And this is also, again, super simple. You can see here on the init, I grab the phrases, I map them into this internal concept of options. The options have a value, an ID, and a name. And you'll see that there's nothing in here about reactive forms, because I prefer template-driven forms. I find them to be very powerful and without all of the ceremony that comes with reactive forms. The HTML for this view is also super simple. I'm just looping over the list of options. I'm using ngModel to automatically update my internal view model as the user types. ngModel, awesome, one of the best things since sliced bread. If you're not using ngModel, you are truly missing out. And then you can see if I submit the form here, let's go down to the submit. If I process the form, all I do is I take those options, I map them back onto an array of values, and then I emit those values. So again, we're using a two-way data binding internally with ngModel, but from an API, from a component API standpoint, we're still using a unidirectional one-way data flow. So there's nothing inherently wrong with mutating data. with something like ngModel, especially when it's an implementation detail of an encapsulated component. Don't hate on ngModel, don't hate on two-way data binding. It's really, really an amazing concept, and it can make your development process much easier. So now that we've seen the edit form and we've seen the bingo board, let's take a look at the app component, which is what glues all of this together. So the app component, let's look at the view first. The view for this component is fairly straightforward. It has two modes. It has play mode and edit mode. And, it's not a super robust component. The rendering of each of these is deferred mostly to the lower level component. Obviously, we have some higher level actions for the app component itself, but you can see we have a bingo board. We pass in our unidirectional data flow of phrases. If we're in the edit mode, we have our form, again, passing in a unidirectional data flow of phrases. We're listening to the phrases change event to apply the new phrases to the board. The app component itself, like half of this code is the HTML to Canvas usage. So apologies for it being maybe a little bit more longer than it would be otherwise. It has a set of default phrases, which I borrowed from this vault.com article on Zoom Bingo, because the point here was not to come up with phrases, the point was to come up with the game itself. There's nothing terribly interesting about this. Essentially, if we look at the init here, we default by trying to pull the state out of the location hash, right? Again, if we look here, we can see we have this large base64 value, base64 URL value. So we default to trying to pull things out of the state. If we look at the apply hash, what you can see is if there is no value, right? So if I come in here and I remove this, you'll see that we end up with a base64 URL encoded value anyway, and that's because if none's provided by the hash, we take the current phrases and we persist them to the URL so that now you have kind of a codified game state. Otherwise, we base64 URL decode the value, split it up into phrases, and then apply those phrases to the board. And you'll see if we look at the HTML again for the edit mode, we're listening for this phrases change event, and then we're applying new phrases. And if we look at the applying new phrases here, you can see it takes that emitted value, saves it to the local phrases view model, and then saves those phrases to the URL. So basically when the app loads, we try to pull the values out of the URL, and then when we update the values, we then push them back to the URL. And this way, if you edit the form and change your state, you can then copy paste the URL to another coworker, for example, and they will see the same board you see, albeit with a randomized collection of values. You can see as I refresh here, the entire view state of the board changes. And again, using the HTML to Canvas library, we can then take a screenshot here, which will codify the state of the game in an image, in a PNG using the underlying Canvas object, which is pretty cool. HTML to Canvas is pretty awesome. There's some limitations. You'll see that this is a fixed width and a fixed height, and I had to do that, otherwise I get some strange clipping behaviors by the HTML to Canvas. So anyway, this was just sort of a fun little code cut I did over the weekend, and a nice exploration of Angular. Some takeaways here. Again, I truly love using ngModel with my template-driven forms. I think it just makes life really, really easy. The two-way data binding provided by ngModel means that I don't have to worry about keeping track of everything. It just updates automatically. And again, I can do that while still maintaining a unidirectional data flow. In fact, you can see that the change detection for my lower level components is on push, so it only operates on input and output changes and then local events within the component. And everything just runs very smoothly. So anyway, again, just a fun exploration. Hopefully there was something in this that was halfway interesting.